See, next one is the problem which is given on the loss of stress due to the anchorage. Okay, so percentage of the loss due to the anchorage you have to determine. Due to the anchorage slip you have to determine. Okay, so in this, a concrete beam is a post tension by a cable carrying a initial stress of 1000 Newton per mm square. Okay, so you can see here. Okay. Mm. Little bit okay of initial stress, it has been given as 1000 Newton per mm square. Okay, a slip of at the jacking end is was observed as to be 500 Okay, so anchorage slip, there is a jacket at the end. Okay, so that one, it has been a slip, there is a small slip in the anchorage. That slip is been observed as 5 Okay, you can see in the second line, the slip in the jack, it is been observed as 5 and the modulus of elasticity of the steel is 210 kilonewton per square. So you have to estimate the percentage of the loss of the stress due to the anchorage slip if the length of the beam is 30 meter and 3 meter. Okay, so you have to estimate the percentage of loss of the stress, you have to estimate. So one beam length, it is been given as 30 meter and another is 3 meter, you have to determine. Okay, we know that the loss of the stress, see here, the loss of the stress is loss of the stress due to the anchorage slip is this es into delta divided by L. Okay, this is the loss of the stress due to the anchorage slip. Okay, so by using this formula, you can find out the only the loss. Okay, so after finding the value by using the loss of the stress due to the anchorage slip, so what you have to do is you have to take the stress, you have to take the stress from the this formula, which find you have to find out the stress with by using this formula. After finding the stress by loss of the stress by using this formula, that that stress and the stress which is initial stress which whatever we have given, so by from one to another, the initial stress, it is been given as 1000. So the stress which is being determined from this one and this one, you take the difference and find out the what is the loss. Okay, percentage of the loss in the anchorage slip. Okay, so one you have to find it for 30 meter, another you have to find it for 3 meter. Okay, so don't forget, you have to find it for 3 meter and the 30 meter both. Okay, so that is about the only the introduction about this problem. So next, what you have to do is you take the problem and find out the anchorage slip. So how to find out that? See here, this is the formula which I shown. Okay, come here. So this is the formula which you have to be used. Okay, so here, here, the for the 30 meter long beam, see here, for a 30 meter long beam, first you take for a 30 meter long beam. So loss due to the anchorage slip, use the same formula, es into delta divided by L. Okay, so Young's modulus which is being given, that is here 210 kilonewton per square. You put the E value as 210 kilonewton, you put it as 10 to the power of 3. Okay, this here, there is a, here they are given the delta value, they are given what is the delta value is. See here, delta value you have to insert it. The delta value is nothing but here 5 is given, that is the anchorage slip. Delta is nothing but the anchorage slip, that 5 is given. So what you have to do is you have to insert the value for 5 for the delta value here. Okay, so that is 5. Okay, 5 value is nothing but delta value. So length of the first one we have taking for the length of 30 meter. See here, the length which we have taken for the 30 meter, so that's why you put it 30 meter here. Okay, sorry, here. Okay, but the length is in meter, they are given in the meter, you have to put it in the millimeter. So convert that, multiple by 1000. So by putting the multiple by the 1000, that will be converted into millimeter. Okay. So finally, if you calculate this value, only this value, you will get it around 35 newton per mm square. Okay, so this is what the loss of the steel for the 30-meter long you have got for the loss of the stresses due to the anchorage slip for the 30-meter long beam. Okay, this is the loss you got it. So now what you have to do is, the initial stress they have given as 1000. Okay, so initial stress they have given as 1000. So final stress, the loss of the stress due to the anchorage slip you have determined as 35. Okay, so you take one by one, you divide it and find out the what is the loss, percentage of loss. So consider there is a 1000 rupees in your pocket, means 35 rupees you have been lost. So what is the percentage of loss means, what you have to do it, so 35 divided by 1000 you do it, so you will get the percentage of the loss. Okay, so 35 rupees is the you have lost. Okay, so that is what 35 rupees. So this is the initially 1000 rupees was in your pocket, so 35 divided by 1000 into 100 you will get it. So 3.5 percentage is the loss. Okay, so that you money you take it in the form of the loss in the stress. So that's how you can find out the loss. Okay, next you take it the for the 3-meter length. Okay, 3-meter length, you take the same formula, es into delta divided by l, so that as the loss due to the anchorage slip. E value, same value you put it, that is sorry, that is the 3 into 210 into 10 to power of 3 you put it, don't forget. E value is 3 210 into 10 to power of 3. So that is what it has been given in the, it is given in the question here. Okay, so same value, E value you have been inserting. So anchorage slip whatever they are given, so that same value you are been inserting here also, that is 5 mm. Okay, so length here only changes length. Okay, length here you have to put it here is 3 meter, because you are finding for 3 meters. So that's why you have to take it L as here, L as see here, L as 3 meter. Here the main the loss of the stress due to the anchorage, that is L, it is 3 meter. So you're finding for the 3 meter, so that's why you have to take it 3 meter. Okay, don't forget. So length only changes, the E is common and delta will be common for the both 3 meter and 30 meter. Only change is the length, that is 3 meter you have to put it for this one. Okay, so finally the stress will be 350 newton per mm square. So after calculating this term, so finally you will answer, you will get it around 350 newton per mm square. So now the initial stress is 1000 newton per mm square. The loss, loss is 350. So what you do is, 350 percentage of the loss in the stress is, so 350 divided by 1000 you do it, so you will get the percentage of loss. So 350 divided by 1000 and multiple by 1000, multiple by 100 you do it, so you will get the 35% as loss. Okay, so for a 30-meter long, the anchorage the percentage of loss is 3.5%. The for the 3-meter length of the span, the percentage of loss is 35 percentage. Okay, so that's about the problem on the anchorage slip. So we'll go for the next problem.